Hello everyone, and welcome back, and welcome to our lesson on projections and coordinate systems. In this lesson, I'm just going to give you a quick overview of what projections and coordinate systems are in GIS, similar to what you learned in the first class if you took that with us. This will set up some foundational knowledge and context for you as we go through the rest of this lesson. To start off, imagine two data sets with coordinates in them. One has coordinates with x values ranging from 36 to 45, and the other has x values ranging from 4 million to 5 million. Are these sets of coordinates comparable? Are they even in the same coordinate system? Or they could be in different coordinate systems. If they're in the same coordinate system and 36 to 45 is over here and 4 million to 5 million is over here, that's possible, but we don't know. Another thing we don't know is, are they even on this planet? There are coordinate systems for the Moon and Mars, and without some other context, we don't yet know what these coordinates describe. Now, if they're in different coordinate systems, but we incorrectly assume that they're in the same coordinate system, we'll have data alignment issues because the small numbers will be over here and the big numbers will be over here. They're probably in different coordinate systems though, but knowing that opens up a whole new problem to us. How do we translate them to a common coordinate system so that we can compare them and view them spatially? Those big numbers don't align with those small numbers, and we need some sort of translation to tell us how they line up on Earth. So, why do we care about coordinate systems? We just hit on one piece of that. We need to align data. So our data needs to share a common reference in order to be used and combined in GIS. Another issue is that we need to know how our data is stored, because how we do that affects its reliability for different uses. And then last, different projections and coordinate systems focus on different locations and applications. They have higher specificity in certain areas or higher accuracy. So stepping back a little, what is a coordinate system? Well, first, coordinate systems define the units that we use for our geospatial data. Second, coordinate systems are built on an origin location. So in GIS, this needs to be anchored to a model of the Earth. In basic math, we would call that origin point 0, 0, but in GIS, we call this model the datum, and we still need to specify an origin point in the coordinate system based on a model of the Earth on the datum. We'll learn about what datums are in the next lecture. So the most basic coordinate systems we use, and the ones that you're most familiar with probably already, are geographic coordinate systems. And these describe locations on the spherical surface of the Earth. And to build one of these, we require a datum, which I just mentioned, which is basically an Earth model, and a prime meridian, which is a line representing an origin for angles, and then an angular unit of measure that helps us know how we move away from that prime meridian, what kinds of coordinates we use when we move away from that prime meridian. We're used to these in other systems and maps that have latitude and longitude, and they're a foundational coordinate system in most GIS. On top of geographic coordinate systems, we build projections or projected coordinate systems. Think of it like this. Since we need an angular unit of reference to appropriately locate things on Earth, a projected coordinate system ultimately ties everything back to our geographic coordinate system in order to locate things. Projections are what allow us to unwrap our sphere-like planet and display portions of it on a flat surface like screens and pieces of paper, but with some consequences for the data. In general, map projections distort at least one of these items, and often more: shape, area, distance, direction, and scale. If we had a projection that preserved all of those locations, we'd use it everywhere. But since it's impossible on a 2D surface, we create compromised projections that optimize for the task or location at hand. So that's it for this lecture. This lecture is a quick overview of what projections and coordinate systems are. We talked about geographic coordinate systems that tie everything back to our spherical model of the Earth, and projected coordinate systems that sacrifice some specificity but build on top of those geographic coordinate systems so that we can display and analyze geographic information on flat surfaces like your screen. See you in the next lecture.